Hello students, once again welcome you to GK's Maths classes. Today we are going to do continuation of chapter 1. Already we have done 4 videos on relations. So today we are going to start with definition of function, and we are also going to discuss different types of function, and then we are going to do solve exercise 1.2. Okay, so let's straight away get into the chapter. So what is the definition of a function, or what is the connection between a relation and why it is called relations and function? So a relation F from A to B is called a function. Remember, a function is a relation. A relation F from A to B is called a function. A relation is called a function when if every element in the domain is mapped to a unique element in the codomain. All these definitions are from class 11th. You have done functions in 11th, so I'm just touching that a little bit revision, and then we'll straight away get into the main chapter. So a relation F from A to B, it is a relation, but it is called a function when it satisfies a specific property. What is that property? That every element in the domain should be mapped to a unique element in the codomain. Every element in the domain should be mapped to a unique element in the codomain. Now, since F is a function and you said it's also a relation, clearly F is also a subset of A cross B. Just like relation, a relation R from A to B is a subset of A cross B. So the function should also be a subset of A cross B. Okay. Now here, since I'm starting from A and I'm going to B, my A is called the domain. A is the domain and B is called the codomain. Okay. And the values that F takes A to B, the values that are taken from A to B, okay, is called the range. Well, I call it as, say, F of A. F of A is the range, which is always a subset of B. A range is always a subset of codomain. The values of A under the function F to B. So my range is in B. Let's take some simple example. Suppose if I have 1, 2, 3, and here I have, say, A, B, C, D. Is this a function? Yes, this is definitely a function because every element in the domain is mapped. What is the domain here? Domain is 1, 2, 3. Every element in the domain is mapped, and 1 is mapped to only one element, 2 is mapped to only one element, 3 is mapped to only one element. So every element in the domain is mapped to exactly one element in the codomain. Therefore, it satisfies the definition of a function. Therefore, this is a function. This is not a relation. You don't call it a relation, but you call it function. Now, what is the domain? Here my domain is 1, 2, 3. What is my codomain? My codomain is A, B, C, D. And what is my range? Range is set A. This element A. Because 1, 2, 3 takes value A. Okay, let's take another diagram. 1, 2, 3, A, B, C. Let's say for example D. I have a connection like this. So is it a function? So let us say this is A and this is B. Yes, this is a function because every element in the domain is mapped. Every element in the domain is A, every element is mapped. To how many element? 1 map to only one element. To how many element 2 map to? Only one element. To how many element 3 map to? Only one. So it satisfies the definition of a function that every element in the domain is mapped to a unique element in the codomain. Therefore, this is also a function. I will just represent f so that I know it's a function. So, what is my domain? My domain is 1, 2, 3, no change. What is the codomain? Codomain is A, B, C, D. And what is my range? My range is B, C, D. Okay. In fact, these two can also be written like this. See, F is, you can write it as an ordered pair. 1 comma A, 2 comma A, and 3 comma A. How do you write this? F is equal to 1 comma B, 2 comma C, 3 comma D. Because you also said F is a subset of A cross B. So the elements in F should also be an ordered pair. Now let's go to the next diagram. A, B, C, 1, 2, 3, say for example 4. Now is this a function? This is A and this is B. This is not a function because the definition of function is not satisfied. What is definition of function? Every element in the domain should be mapped. Now here, every element in A is not mapped. A and B is mapped, but C is not mapped. C do not get mapped to any element in B. Therefore, this is not a function, whereas it is called a relation, denoted by R. And I'm not interested in relations. I'm more interested in functions. Okay. So this is a relation, but it cannot be called a function. This is a function, but you can even call it as a relation, no issue. But so all functions are relations, but all relations need not be function. Very important. All functions are definitely relation, but all relations are not functions. Let's take one more diagram to understand what 1, 2, 3, A, B, C, D. Is it a function? Yes, it looks like every element is mapped. Every element in the domain is mapped. Every element in the domain is mapped. But if you notice carefully, 3 is mapped to 2 elements. 3 is mapped to 2 elements. Since 3 is mapped to 2 elements, it violates the definition of a function. Therefore, this is not a function, whereas this is just a relation. Okay? So I hope you understand the difference between a function and a relation. I also feel that you must have understood when will a relation become a function. A relation becomes a function if every element of the domain is mapped, and every element of the domain, each and every element of the domain gets mapped to exactly one element in the codomain. Then you say it's a function. Otherwise, you just give a common name called relation. Okay. Now, let's go to some diagrammatic representation. Now, suppose if I have an equation, say x square plus y square equal to 25. You all know in class 11th, x square plus y square equal to 25 is a circle. It's a circle with center, origin and radius 5. Can I make a statement that this is a function? No. Why? Because we have something called a vertical line test. If I draw a vertical line, you can see clearly when the vertical line is moved, okay, the vertical line intersects the curve at more than one point. The meaning is, see, this is a set of all real numbers. Okay, this is your x-axis. And this is set of all real numbers, which is your y-axis. So for one value of x, let me call it x1. For one value of x, you have two different values of y. What are they? y1 and say minus y1. Correct? So it violates the definition of a function. So clearly x square plus y square equal to 25 is not a function. And how did I verify? I used vertical line test. A vertical line test is simple. If you draw a vertical line to a curve, if it intersects the curve at more than one point, it cannot be a function. I'll give one more example. Say y square equal to 4x. You know y square equal to 4x is a parabola. Y square equal to 4x is a parabola with vertex at origin and symmetric about positive x-axis. Now what I will do, I'll take this vertical line and I'll just move it. So what happens to the vertical line? It at a given point, it intersects the curve at more than one point. Therefore, this is not a function. This is not a function. This is also not a function. Okay, it's not a function. So vertical line test helps you to understand whether the given graph is a function or not. I'll give you one more example. Suppose let us take x square equal to 4y. Now what is x square equal to 4y? It's a parabola symmetric about positive y-axis. Now let's take this vertical line. So if you move this vertical line wherever you want, you can see clearly at every given point it intersects the graph exactly at one point. Can you see it? It intersects at exactly one point. Okay? Therefore, this is a function. So what does vertical line test say? When the vertical line cuts the graph at exactly one point, when you keep moving, then it is a function. If it intersects at more than one point, it is not a function. Okay. Now let's look at the semicircle. Let us take x square plus y square equal to 25. So I will take y square equal to 25 minus x square. So y equal to plus or minus root of 25 minus x square. So if I take positive square root, I get the upper part of the semicircle. This is actually y equal to root of 25 minus x square. If I take negative square root, I will get the lower part. Now you can see clearly what happens to the vertical line. When I move this vertical line, wherever you move, it intersects the graph at only one point. When you keep moving it, it intersects the curve at exactly one point. Therefore, the circle is not a function, but the semicircle, this is a function. It satisfies the definition of function. You can also look at this. You have y square equal to 4x. So y will be plus or minus 2 root x. So if I take the negative part of it, it will be a graph like this. Parabola, you get the lower part. This is y equal to minus 2 root x. Just for a change, I took minus 2 root x. Now, if you move the vertical line, see what happens. When you move the vertical line, wherever you want, it intersects the graph at exactly one point. Okay? Therefore, this is a function. So this is a very simple example of a function. So now you should have understood what a vertical line test can do. A vertical line test helps you to estimate whether the given relation is a function or not. If the graph is intersected by the vertical line at exactly one point, then it is a function. If it is intersected at more than one point, it is not a function, it is a relation. I'll give one more example of a curve. For example, if I have a graph like this, is it a function? Definitely no, because if I draw a vertical line, it intersects the graph at more than one point. Let us take a sine curve, sine x curve, So sin x square. If I draw a vertical line, it intersects the graph at exactly one point. So this is a function, whereas this is not a function. I hope now you understood from the graph how to estimate whether the given graph is a function or not a function. The simple idea is use vertical line test. So now that you have understood what a function is, okay, you understood the definition of function, you understood how to look at a graph and say whether the given graph is a function or not. Now we are going to talk about different types of function. The first type of function is called one-to-one function. Okay, you can say one-to-one function, otherwise called injective. It is called one-to-one function, otherwise called injective function. Very, very simple. The definition is this: distinct element gets mapped to distinct element. Distinct element in the domain gets mapped to distinct element in the codomain. Simple. Okay. So if f is a function from say a to b, if f is a function from a to b, I will say it is one-to-one when for every x1 comma x2 belongs to a, I take two elements x1 and x2 where in the domain, okay, and if f of x1 equal to f of x2, where f of x1 will be in b, okay, in b, then you can say x1 equal to x2 where in a. Or if you don't like this, or you can also have this, f of x1 not equal to f of x2 implies x1 not equal to x2. So let's understand this diagrammatically. A, B, C, D, E, F, G. A go to G, B go to F, C go to E. You see, 1 to 1 element in the codomain can be left out. Now A go to only one element, B go to only one element, C go to only one element. This is a simple diagram to understand that the given function is 1 to 1. I'll give you another example where it is not 1 to 1. Always counter examples will help you to understand things better. 1, 2, 3. This is not 1 to 1. See, A and B are different, but they get mapped to the same element. Okay, my f of A and f of B. Here my f of A and f of B are equal. They are equal, but A and B are not equal. Therefore, this is not 1 to 1. In fact, people give a special name called it is many to 1. What is it called? Many to 1. Whereas this is 1 to 1. 1 to 1 or injective. So these two diagrams should definitely make you understand what a 1 to 1 function is. So when I say x1 and x2 not equal to A, see A and B are not equal, f of A and f of B are also not equal. But there's another way to understand 1 to 1 function graphically. This is called horizontal line test. Line test. Now what does the horizontal line test do? I'll take two counter examples. Okay, let me take for example x square equal to 4y. First of all, it should be a function. Definitely it is a function. So what is the graph of this function? The graph of this function is a parabola with vertex at origin and symmetric about positive y-axis. Now I want to draw a horizontal line. So now when I draw a horizontal line, if the horizontal line intersect at more than one point, then it is not 1 to 1. Okay, why? Very simple explanation. Look at this value. This is x1 and this is x2. Definitely they are not equal. Correct? x1 and x2 are not equal. One is on the negative side, other one is on the positive side. But what are the corresponding y values? F of x1 is same as f of x2, or you can say this is your f of x1, this is your f of x2, and they are equal. Therefore, f is not 1 to 1. F is not 1 to 1. If you want a numerical example, you would take -1 not equal to 1. Now what is f of -1? F of -1 will be, if I put it here, it will be 1 by 4. Okay. I put x as -1, so y will be 1 by 4. What is f of 1? That is also 1 by 4. So clearly f of -1 equal to f of 1. So -1 not equal to 1, you can say this is -1, this is 1. -1 not equal to 1. F of -1 is not equal to f of 1. F of -1 is equal to f of 1. So this is definitely not 1 to 1. So the easiest way to understand is a horizontal line, if it intersects the graph at more than one point, it cannot be 1 to 1. It cannot be 1 to 1. Okay. I'll give another graph. Let us take y equal to square root of y equal to square root of x, or y square equal to 4x. So I'll take y equal to 2 root x. I'll take the positive square root. Now this is the graph. Okay. Let me draw a horizontal line. When I draw a horizontal line, and if you keep moving it wherever you want, you see it will intersect this graph at exactly one point. So since it intersects the graph at exactly one point, this is a very simple case of a one-to-one function. This is 1 to 1, whereas this is not 1 to 1. I hope you see the difference. This is 1 to 1, this is not 1 to 1. Okay. So the another name for 1 to 1 function is injective. Okay. I hope you understood the definition, and I have given you different ways of looking at an injective function. Okay. Now, what's the next one? I need some space. So, okay. Let's go to onto function. Onto function. Otherwise, it is called surjective. What is it called? Surjective. Onto function, otherwise called surjective. Now, what is this onto function, or what is the meaning of surjective? If f is a function from a to b, and I call it surjective, or I call it onto, when do I say that? Very simple. When codomain equal to range. And codomain equal to range. Or you can say every element in the codomain, have a pre-image in the domain. Okay. Let's look at this diagrammatically. A, B, C, D, E. Is it a function? Yes, it is a function, because every element in the domain is mapped to exactly one element in the codomain. A is mapped to one element, B is mapped to one element, C is mapped to one element. So this is my A and this is my B. Domain is known, codomain is known. So what is my codomain? My codomain is D, E. And what is my range? My range is also D, E. So clearly codomain equal to range. Therefore I can say F is onto. Or otherwise, the pre-image of E is C. Pre-image of D is A and B. Every element in the codomain have a pre-image. If every element in the codomain have a pre-image, then you call that function as onto. Now, let's take a diagram. Say A, B, C, D, E, F, G. A go to this, B go to F, C go to, for example, this. Okay, no problem. So what is your codomain? Codomain is D, E, F, G. And what is my range? My range is F comma G. Clearly range not equal to codomain. If the range is not equal to codomain, F is not onto. Or in other words, the pre-image of F is A and B. Pre-image of G is C. But D and E do not have pre-image. If D and E do not have pre-image, you see, every element in the codomain have a pre-image. Here D and E do not have a pre-image. Therefore, this is not onto. This is one-to-one. So this is onto, whereas this is not onto. So always understand these two examples to make you understand whether the given function is onto or not. Okay, so you understood what a one-to-one function is, and you have also understood what an onto function is. I hope it's clear. Now the next one is called bijective function. Bijective function. What is a bijective function? F from A to B is bijective. When it is bijective? If F is injective, injective means one-to-one, and it is also surjective. What is surjective? Surjective means onto. If a function is both one-to-one and onto, if the function is both one-to-one and onto, you call that function as bijective function. Let us take some example diagram and I'm going to try to understand. Suppose I have A, B, C and I have 1, 2, 3, 4. What name will you give for this function? Clearly, this is one-to-one only. It is only one-to-one because two do not have a pre-image. Okay. Let's look at the next diagram. I have A, B, C, D and E. What do you say about this? This is onto only. It is definitely not one-to-one because A and B are going to the same element, many to one, so it cannot be one-to-one. Now look at this third example. 1, 2, 3 and you have A, B, C. 3 goes to A, 2 go to C and 1 go to B. What do you say about this? This is clearly one-to-one and it is also onto. Since it is one-to-one and onto, I call this as bijective. I call this as bijective. So if a function is both one-to-one and onto, then it is bijective. Now this part of the thing which I am saying is not in the syllabus, it's been removed, but it is very important that you know because then only you can understand inverse trigonometric function. Okay. So when does the inverse exist? Now I have taken my function from A to B, right? I have gone from A to B. Now I want to reverse, I want to come back, I want to come from B to A. Okay. So when, okay, I'll go to the next page. Okay. So F inverse, this is a notation for inverse. F inverse from B to A exists. When does it exist? F inverse from B to A exists only if F from A to B is bijective. F inverse from B to A will exist only when F from A to B is bijective. If F is not bijective, F inverse cannot exist. Why? Let us look into this quickly. See this. Let's look at this examples, okay? I'll take this to the next page. Now, I have this example. Now look at this. This is only 1 to 1. Now, this is from A to B. This is from where to where? A to B. Now, when I want to do B to A, this also must exhibit the definition of a function. But clearly you can see f inverse cannot be a function. Even though f is a function, this is f, okay? This is f. F is a function, but f inverse is not a function. Why? It is not a function because now you understand my B becomes my codomain. For f inverse, B becomes my domain. I'm sorry. For f inverse, B becomes my domain. So every element of the domain is not mapped. 2 is not mapped to any element. Therefore, it violates the definition of function. Therefore, f inverse cannot be a function. Why it is not a function? Because it is only 1 to 1. Now look at this example. Even though all the elements here are mapped here for f inverse, E is mapped to 2 elements, which again violates the definition of a function that every element in the domain is mapped to exactly one element in the codomain. Therefore, this is also not a function. Whereas if you look at this, this is a perfect example of a function which has inverse because here f inverse will exist. Why? Every element is mapped and every element here is mapped to exactly one element in the codomain. So if you want to talk about inverse of a function, definitely it must be 1 to 1 as well as onto. Okay, we will not go in detail about that because we don't have it in our syllabus. But all that I want you to understand is f is bijective means f has to be 1 to 1 and onto. Bijective is a necessary condition for inverse to exist. Okay. Let's go back to the problems. Now the first question we are going to do is, I hope you understood all the definition. The first question we are going to do is, show that the function f from r plus to r plus defined by f of x is equal to 1 by x is 1 to 1 and onto. Where it is from r plus to r plus. That means all positive real numbers excluding 0. Already they have excluded 0, therefore the function is well defined. If they are not excluded 0, then 1 by x cannot exist. Okay. So let us see how to verify 1 to 1. So right now my function is from a set of all r plus to r plus. Out is defined as f of x is equal to 1 by x for every x belongs to r plus. This is from the domain. Okay. Now I want to verify whether it's 1 to 1 or not. Now, for every x1 comma x2 belongs to r plus, I am verifying 1 to 1. For every x1 comma x2 belongs to r plus, if this condition is true, what is that condition? If my images are equal, f of x1 equal to f of x2. But what is f of x1? F of x is 1 by x. F of x1 will be 1 by x1 equal to 1 by x2. Now you cross multiply, you will get x1 equal to x2, which satisfies the definition of a 1 to 1 function. You see, I have given you the 1 to 1 function definition, which satisfies the definition of a 1 to 1 function. For f of x1 equal to f of x2, x1 equal to x2. Since it satisfies the definition of a 1 to 1 function, I can say clearly f is 1 to 1, otherwise called injective. Okay. Now, how do I find? This is for 1 to 1. Now I want to talk about onto. For onto, what I should do? I should prove that the codomain and range are equal. So let us see. I have y equal to f of x, and f of x is given as 1 by x for every x belongs to r plus. Okay. Now what I will do? I want to know what values y can take. Okay. So I will say x is equal to 1 by y, right? I just cross multiply. X is equal to 1 by y. Clearly, y can take any value except 0, right? Y can take any value except 0. And I don't have to worry much about it, about 0, because already it is removed. F is a function from R plus to R plus. In both domain as well as in codomain, it is set of odd non-zero real numbers. Okay. Therefore, y belongs to all positive real numbers. So my range is also R plus, so is my codomain. Therefore, F is onto, otherwise called surjective. I hope you understand. All that you need to do is find x in terms of y and check what are the values y can take. Now clearly y cannot take 0. Y can take any other value. So y takes all positive real numbers. Here I am limiting myself to positive real numbers, so I restrict to positive real numbers. Y can take all positive real numbers except 0. So my range is R plus. But my codomain is also R plus. Codomain equal to range. Therefore F is onto. Okay. So that is exactly what I wanted to find. Now there's another part of the question. Is the result true if the domain is replaced by set of all natural numbers? Okay. Suppose if I have a function, f, not from R plus but from natural numbers to R plus. From natural numbers to R plus, can it still be 1 to 1 and on to? Okay, let us see. For every x1 and x2 belongs to natural numbers, if this is true, okay, only if this is true, f of x1 equal to f of x2, that means 1 by x1 equal to 1 by x2. Obviously, you can say x1 equal to x2. If it is true. If it is not true, then it will not be true. If f of x1 not equal to f of x2, x1 will not be equal to x2. If this is true, then you can say f is 1 to 1. There is no change. Whether it is R plus or n, it makes no difference to me. Whether it is on to, let us see. Let us take an element 2 belongs to R plus. Where? In the codomain. Okay. Say for example, this is 2 in the codomain. Now this is my natural numbers. So it should come as what? 1 by 2, right? The pre-image should be 1 by 2 because the function is defined as f of x is equal to 1 by y. X is equal to 1 by y means y equal to 1 by x. So when x is 1 by y, if it is 2, what will be the value of y? So here clearly 2 belongs to R plus, then 1 by 2, I can say the pre-image of 2 belongs to R plus is 1 by 2, which does not belong to natural numbers. The pre-image of 2 is 1 by 2, which does not belong to natural numbers. Since 2 does not have a pre-image, my codomain is not equal to range. My codomain will be R plus. My range is not R plus because 2 is not possible. I gave one example. You can give any example. If you give one example to say it's not onto, then it is not onto. Okay. So codomain not equal to range. Therefore, F is not onto. F is not onto. From where? From N to R. Again, I want to repeat this onto part. I took 2 belongs to R plus in the codomain. Okay, and its pre-image is 1 by 2, but 1 by 2 is not a natural number. Therefore, clearly 2 do not have a pre-image. But definition of onto is what? Every element in the codomain should have a pre-image. So since 2 do not have a pre-image, my codomain, which is R plus, and my range cannot be R plus. Okay, so codomain not equal to range. Therefore, F is not onto. Okay, I have more questions to do. Maybe we'll do it in the next video because it becomes too lengthy then. I hope you understood the definition, and I have started with question number 1. In the subsequent video, I will be doing more problems on functions. Okay, kindly subscribe to my channel and also click the bell icon to get notification. I hope it's clear to you. Okay, thank you very much. Have a nice day. See you again in the next class. Bye-bye.